Given to you is a dam, and the dam is filled with water up to some height. Let us say this is the dam that I'm talking of, and it is filled up to height capital H. Find it.
Yes,
A
sir.
dam certain breadth, certain length is filled up to height capital H. Let us go by the common abbreviations. So L is the length and B the breadth. Clear? Yeah? H the
Yes.
height it is filled. And we are talking of it being filled with water. So row of water being known to us. If so, we will use it. If so required. For now, I'm going with the empirical form. So I wish you get me. What will be pressure on the walls of dam? Walls of dam will experience what pressure or what force it is to translate to. The pressure that the walls are to experience will get us what equation on force. So how am I to calculate force at any point? When I multiply pressure at that point with the area associated to it, corresponding to it, correct? Yeah.
Yes,
Yes.
sir.
So if I am to find pressure at any point, then I have to specify level of that point or depth of that point, correct? Yeah, because we are
Yes,
now
sir.
to pressure being either point specific or level specific, correct? Yeah.
Yes, sir.
Let me be an ask. Can I get in one shot pressure acting on the wall? Of course, you have to say no. It is a redundant question. Why so? Because pressure is beholden by depth, correct? Yeah.
Yeah. Yes.
Yes, sir.
What is the pressure equation to us? Known to all of you, P naught plus rho g h. H is the depth taken here, correct?
Yeah. Yes, sir.
Yes, sir.
Small h, is it okay? So a
Yes.
small h is depth taken at this level. Anywhere you can calculate the pressure to be P naught plus rho gh. If you are going with P naught, then P naught plus rho gh. If you want to go in isolation, bereft of P naught, then it will be rho gh. Find it.
Yes,
Yes,
sir.
sir.
Anyway, I'm going with P naught plus rho gh to begin with. So this is the pressure equation. And what I mean to ask you is, this pressure equation is applicable at a point. We know that very well. But how can I get force from pressure equation? I can never get force from pressure equation till the time I'm applying force with the corresponding, however it may be, but the corresponding area. Are you in agreement with this thought process?
Yes, sir.
Yes, sir.
If I am in need of force, which I am certainly, then I'll have to get the corresponding area or the area of operation. Yes or no?
Yes, sir.
And the area of operation over here should not change level. Are you getting it?
Yes, sir.
Yes, sir.
Operation should not change level. Because if I'm changing level to get area, I am recording more than one pressure, correct?
Yes, sir.
Yes, sir.
So I am not being in any, if I am to change, let's say if I want to find what will be pressure at a particular point, I need to fix the level. But at the same time, the contention being that I have to associate area. And if I have to associate area, then I have to associate thickness. Thickness with the level that I have taken. Why will I have to associate thickness with the level that I have taken? Because one of the dimension will be the length, correct?
Yes, sir.
One of the dimension will be length. If I take length inside and this being breadth, then one of the dimension of the strip that I'm talking of will be length. Agreed or not? Think about it here.
Yes,
What
sir.
I'm trying to suggest. One of the dimension will be length. But length in solo is not to get me the area. So what I have to do? I have to apply multiplication of this dimension with the other dimension. But the moment I take other dimension, the moment I'm taking other dimension, I'm disturbing small h. Agreed?
Yes, sir.
Are you getting it or not? I'm disturbing
Agreed.
small h. Why? Because I need width to be associated with level, correct?
Yes, sir.
Yes,
This is
sir.
the predicament. The predicament being I cannot go with level only. I'll have to take area into consideration. The moment I take area into consideration, pressure varies as pressure is beholden by height or depth, correct?
Yes, sir.
Yes, sir.
So what is the way out? What according to you should be the way out so that I get area, yet I don't get any considerable change in pressure? it is beyond our hat to say pressure will not change. You know that very well. Because the moment,
Yeah.
howsoever small it may be, howsoever insignificant it may be, the moment you are changing H, then pressure at different value of H will read differential values. Right here?
Yes,
Yes,
sir.
sir.
But those differential values, if they are within the limit of what the experimentation will be an allow on, then we can take some liberties, right? Yeah.
Yes, sir.
Yes, sir.
What you suggest? One dimension to me is L. This is the room that I am in, and this is dam to me. This is doing a dam to me, let us say. And if this to do a dam to me, then one of the length will be this, visible here.
Yes,
Yeah,
sir.
yes, sir.
One of the dimension, let me tell. One of the dimension, not length. One of the dimension will be length to me, correct?
Yes, sir.
Yes, sir.
Yes, sir.
And the other dimension, which I should multiply this dimension with, should be of negligible, meager measurement, correct?
Yes, sir.
Yes, sir.
And if I say that should be of meager measurement, meager on scale, and mind you, I'm saying in same breath, so please don't get confused. I said one dimension is length or breadth, whatever you are associating with. If this taken length, if that taken breadth, correct? Yeah. If I take this, then breadth, correct? Yeah.
Yes,
Yes,
sir.
sir.
Yes,
One
sir.
dimension is in our know, well within our reach. The other dimension, if I say H, then I am talking through my hat. While I'm talking through my hat, I cannot take H, as H is not to get me area, right? Yeah.
Yes, sir.
Yes, sir.
H
Yes.
will get me the level at which I want pressure to be calculated. But that pressure is to act on an area. An area to me should be multiple of length and another dimension, correct?
Yes, sir.
Yes.
So length is known to me. Please clear here over the other dimension. What should be the other dimension? So that pressure doesn't vary considerably. Yes, Krish.
So, will it be breadth?
Breath, if I take Krish, then I'm going to the other wall, right? Yeah.
Yeah, yes, sir.
To one wall, I'm to associate length and H. To other wall, I'm to associate breadth and H. Correct? Yeah.
Yeah.
So
Yes,
if
sir.
I'm taking this wall, then length is being fixed. Length will be one of the dimension of area which I seek from you. So that is fine. What will be the other dimension? If you say other dimension will be height, then I'm in a fix. Why? Because height is capital H over here. And if I take capital H, then pressure at different point is to read differently. Correct? Yeah.
Yes, sir.
Yes, sir.
So I have to keep in mind that that rider is always on, and the rider being pressure on the area that I'm talking of should read not a startling change. It should be a change, it will be a change, but that change cannot be startling, cannot be good on measurement. It should be a meager change on pressure.
So
Tell
should the
me here.
dimension be force?
Yes, Adesh.
So the dimension is force.
Force is the dimension and pressure should be multiplied with area to get force, right here.
Yes, sir.
So what shall I multiply it with? What area? What area will this pressure add? What area will qualify? What area will? If I am to use this pressure equation, which I am to, right? You know that very well, correct? So
Yes, sir.
what area will correspond to this pressure value? What area you can say this pressure can be kept a constant to?
So, area of the particle.
Area of the particle, you will say, or as one dimension is fixed, Krish, then why aren't you taking length per se? At least you know that one level pressure will read the same, right? Yeah.
Yes,
So
sir.
why are you thinking about taking length as dimension? Why particle you are reducing to? Particle, of course, will be the case, but more you add to particle, you get that particle converted into a line. So line I don't have any reservation with. Of course, line is on which this pressure is to act. This pressure will act on any line which is at a depth h from the surface, free surface, right? Yeah.
Yes, sir.
So why particle are reduced to? I'm good with line, but solo line is not to me suffice. Why will it not suffice? Because I want with this line area to be associated. Getting it or not? One dimension we don't have much to think about. That is L or B, correct? Yeah.
Okay.
If I take
got
this
it.
wall, it will be L. If I take that wall, it will be B. So that dimension we need not brood upon. I'm asking for that dimension, the linear dimension. How can I make it good to my users? And when can I make it good to my users? When I convert that line into an area. So what area? What area will qualify this pressure being almost the same on it? That is what I'm asking. What area? What should be the area which will qualify this pressure, which will get you the agreement on pressure same everywhere? Come on. One is length, the other capital H you cannot take liberties on. So what should you do to capital H? Come on, yeah. If level is to be maintained, yeah.
We decrease capital H.
Yeah, decrease capital H. Say so then you are at H. So what shall you take the other dimension to be? As small as possible. Say me yes or no.
Yes, sir.
Yes.
But can you do away with that dimension? No, you cannot. Because if you do away with that dimension, you won't get area, right?
Right, sir.
Yes.
So we want area. We want length to be multiplied with another linear dimension, right, Krish? Vedant?
Yes, sir.
So, and there is a rider. There is a rider. And the rider being, I cannot take considerable length. Why? Why? Why can I take considerable length? Why can I go deep? Why can I take this length considerable? Tell me, dear. Come on, all of you.
So there will be pressure variation.
The pressure variation.
Fine.
Yes.
So that I have to keep in mind. I cannot be violative of that rule. I need to adhere to it. Correct, dear?
Yes,
Yes,
sir.
sir.
So if I'm not allowed a freedom on it, if I cannot be violative of it, then as said Adesh, we will try to keep small h as small as possible, right? Yeah.
Yes, sir.
And then we get the small area. What will be that small area? That small area will be L into DH. Agreed?
Yes. Yes, sir.
You
Yes,
can
sir.
say B into DH. No issue. I don't have any problem with it. Correct, yeah? If you have taken
Yes,
the other
sir.
wall, if you're taking the other wall and you are dealing with a cuboid, you can easily go with B into DH. DH will remain same, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So you get a strip, correct, yeah? Do we get a strip of
Yes,
this
sir.
area? Yes or no? A strip. Are you getting it? Are you getting it, yeah? You're getting a strip. Agreed or not? You're getting a
Yes,
strip.
sir.
Agreed or not? Come on, this is the
Yes,
strip,
sir.
correct? This is
Yes,
the
sir.
strip
Yes,
that
sir.
we are getting. Strip of what area? A strip of area L into DH. Correct?
Oh, yes, sir. Yes, sir.
Yes, sir.
Are you getting a strip? Why is that there? Radio silence. Why there was a radio silence? Getting it or not here?
Yes,
You're
sir.
getting a
Yes,
Getting it, getting it.
wall, and then I'm telling you that you got a strip. A strip of what area? A strip of area L into DH.
LDH.
Correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. And on that strip, what force will act? A small amount of force. What will that be? It will be P naught plus rho GH. P naught plus rho GH into the area L into DH. Agreed?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so this is force to us, and we know what we are to do in order to get net force, right? Yeah.
Yeah.
Oh, yes, sir.
Integrate from where to where? Small
Integrate.
h. Small h will vary from 0 to capital H. Can we see
Capital
that?
H. Yes, sir.
Yes, sir.
Yes,
Small
sir.
h varies from 0 to capital H, getting you P naught into L into H. P naught LH plus rho GL H square by 2. Check it out here. I have placed the limit in one go. In one stroke, I have integrated and placed the limits as well. Right here.
Yes, sir.
Okay, right, Krish?
Yes, sir.
Okay. Now, just to get some interest of your drone, let me get you what other ways you can present it. The other ways in which you can present it being rho GH, P naught plus rho GH by 2. Now this is pressure equation at h by 2 height, correct? Yeah.
Yes, sir.
Yes, sir.
Yes,
And
sir.
if you will multiply with the actual organic area, what is L into H? L into H is the area of the wall under concentration. Say me yes or no.
Yes,
Yes,
sir.
sir.
So if you find pressure at the midpoint and multiply it with the area of occupancy of water, correct? Yeah.
Yes, sir.
Yes, sir.
This is the area of occupancy of water, right? Yeah.
Yes,
Yeah.
sir.
I'm not saying volume, area. This is the area up to which water is to be seen touching the wall. Say me yes or no.
Yes, sir.
Yes, sir.
Yes, sir.
That area when multiplied with pressure that the level will generate midways, right?
Yes,
Yes,
sir.
sir.
That is what you can reshape it into. Clear idea? To commit to memory. Easily now you can commit to memory. Any wall given to you. Suppose height of water level in a dam is up to twice h. Are you getting it?
Yeah.
Yes,
Yes,
sir.
sir.
Yes,
When
sir.
is asked what will be false on a wall of area A? What will you say? You
Oh,
will write area
Yes, sir.
P naught plus rho G 2h by 2, correct?
Yes,
Yeah.
sir.
yes, sir.
And then you will get what force will be that wall made to bear, correct? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
No force, you can design a dam. So this is just a prerequisite, you can say, or my help, which I'm tendering for you to solve question given the other day. I have rendered a question the other day, correct? Yeah. And I look
Oh,
forward
yes,
for
sir.
the solution. Please keep in mind, examination is into coming. Find yeah.
Yes,
So a
sir.
small
Yes,
question.
sir.
So for
Yeah.
that question, can we use this one torque equation?
There is no need to go for TOG, dear. TOG, I'll let you know later. As of now, is not required TOR. Right? I will
Yes.
not get you questions for which you have not been lamented on. So we have lamented on those questions and you can easily get a solution to it. Whatever was an extra required, I provided you today. Yes, you'll have to think out of the box. Instead of thinking of cylinder, you'll have to think of the water table.
Yeah. Yes, sir.
Okay, dear. So now with
Yeah.
the help which I tended you today, I think you should be able to get it. And if you are not able to get it, then please re-evaluate your preparation. Sorry to say that, but if you are not able to get it, this is high time to re-evaluate your preparation. Yes, it is going in some other direction. It is not to in any way, I shouldn't say because I have no authority on it, but it is not to any way yield to your efforts. So please rechannelize it. I think you should be able to solve question with these inputs. Clear,
Yes,
dear?
sir.
Else
Yes,
will
sir.
be telling on your preparation. Else will be telling on my teaching. Fine, dear?
Yes, sir.
Okay. So I am banking, I am pinning my hopes on you will be able to get to something in that question. Something means 80 to 85% to the least. Is it okay?
Yes, sir.
Yes, sir.
Okay, let us further then write down. Given a trough is let loose on, given a trough is let loose on an inclined surface, given a trough is let loose on an inclined surface, inclined at an angle theta. Given a trough is let loose on an inclined surface, inclined at an angle theta. find angle that the level of water will make with inclination. Find angle that the level of water or surface of water will make with inclination. So you have let loose, there is no friction present anywhere. This tumbler, this vessel is free to accelerate, and accelerate it will be g sine theta, right? Yeah.
Yeah.
Yes,
So
sir.
it is accelerating with g sine theta. What being asked is the level will make what angle? That means what will be alpha over here? Equal to theta, 0, less than theta, greater than theta. What according to you it should be? Think about it, think minutely, you should get it. What should be alpha and what? Anyone?
1 second.
Okay.
Is tan alpha equal to cosec theta?
Tan alpha equal to cosec theta. Maybe I'll check that. Alpha equal to cosec theta. Anyone else? What should be alpha out here is the question. And
Yes,
we
sir.
know where from we are coming, by the way. Please don't lose sight of what being studied against. The property of a liquid. What is it there? What is property of a liquid? Any liquid that you take, it comes with some trait. And one of the most important distinction being that they cannot withstand any force parallel to their surface, right? Yeah.
Yes, sir.
Yeah.
So if I am to check, will there be force parallel to its surface? Let us try to figure it out. This is mg acting on liquid, and I break mg in two components. One will be mg cos theta, and the other mg sin theta, right?
Yes, sir.
Yes,
mg
sir.
sin theta. mg sin theta is acting in the direction downwards, right? Yeah.
So one
Yes,
second.
sir.
Yes, sir.
Down inclination. Can we say that?
Yes,
mg
sir.
sin theta is acting and it
Yes,
is
sir.
acting down inclination. So if it is acting down inclination, and if I repeat, if I have a mean to neutralize mg sin theta, got it? Yeah.
Yes, sir.
I
Yes, sir.
have a mean to neutralize mg sin theta, then I can be of opinion alpha being 0. Agreed?
Yeah.
Yes,
Yes,
sir.
sir.
We don't
Yes.
have any mean by which mg sin theta can be annulled, can be thwarted. Can we foil it? Can be thwarted? Can mg sin theta be thwarted? And you are known to every other time I have been explaining it to you. Whenever you are to freeze on surface, you ought to be in the vessel under consideration, right?
Yes, sir.
Yes,
So
sir.
if
Yes, sir.
the vessel is moving down with g sin theta, that is there with you. Therefore, you are to apply. That information is there with you. That vessel is moving down with g sin theta because you cannot calculate, right? Yeah. You being
Yes,
in
sir.
vessel cannot calculate. So that information being there with you, you are moving down with g sin theta. You will apply pseudo force of the inclination of the order mg sin theta. Agreed?
Yes, sir.
Yes.
So
Yes,
down
sir.
is mg sin theta, up is mg sin theta, means we have neutralized component of mg down the inclination. Agreed?
Yes, sir.
Yes,
And
sir.
if we have neutralized, then there will be no force parallel to surface if we take which to be the surface. If I take this to be the surface, agreed? Yeah?
Yes, sir.
I take this to be the surface. Anyone having any qualm against it? Anyone
Yes.
having a protest, a
No, sir.
contest to this surface?
No,
Why
sir.
I am intent on taking this surface is because when I take this surface, I am convinced there will be no force parallel to this surface, correct?
Yes, sir.
Yes, sir.
Yes, sir.
So what will I say? Alpha must be 0, right? What
Yes.
should be alpha? Alpha should be 0. That means if you let loose any liquid on a smooth surface, a smooth inclined plane, then it will level itself parallel to the inclination. Correct, yeah?
Yes, sir.
Yes,
It
sir.
will
Yes, sir.
level itself parallel to the inclination. Please check it out. Check it out. Is it fine?
Yes,
It will
sir.
level itself. Yeah, tell me.
Nothing.
It will level itself parallel to the inclination. Anyone having any question on it, please feel free ask.
No doubt.
No, no.
No, sir.
Okay, this is what we'll be getting, and this will be the surface. Try to figure it out also if it's possible for you by using tan theta is equal to a by g. Do you remember? Here you
Yeah,
can
yes,
say
sir.
tan
Yeah, yes, sir.
alpha is equal to a by g. Tan alpha is equal to a by g. A is how much plus A is g sine theta, right?
Yes, sir.
Sine theta. And see what will be the contention over here. I'm just required to highlight it. If you go by okay, tan alpha or theta that we used to get was equated with a by g. A used to be the acceleration. So I'll take acceleration as g sine theta, which is what it is, and then I'll divide it by g. Suppose you are of this opinion that I'll divide it by g. See what you end up getting. You end up getting g cancel, tan alpha is equal to sine theta, and you are very much within your ask. You can, as you have the right to. Why is this result tan alpha equal to a by g not leading to what we got to see practically? Because according to this, tan alpha should be equal to sine theta. So why is this not gelling well with our practical evidences? Isn't it here? It is not, right here?
Yes,
When
sir.
will it
Yes, sir.
suit the bill? When you get tan alpha equal to 0, are you getting it?
Yes, sir.
Yes,
Yes,
sir.
See, then you say that okay, whatever was the inference is a match out here. Here, this is not a match. So why so? Why did the equation tan alpha equal to a by g or tan theta equal to a by g fail us here? Anyone? Anyone? These are the questions asked class. This is a very revered question of any repute competitive examination. You will find almost everywhere in the package this question being there. So, firstly, are you convinced what will be alpha? If you are convinced what will be alpha, which we have found experimentally to be 0, then just trying to stretch it beyond as they can, IIT will, if comprehension being it put in. IIT will ask that why is this equation not gelling well with the experimental under consideration? What will you say to that? The experimentation under consideration is not going well with the equation. Why so? What over here is keeping from users of this equation? Think about it. For now, is this fine with all of you? That the level will be parallel to inclination. Agreed or not?
Yes, sir.
yes,
Yes,
sir.
sir.
Say with horizontal, it will make an angle theta, right?
Yes, sir.
Yes, sir.
Yes, sir.
Horizontal, this level will make what angle with horizontal? Theta only, right? Yeah.
Yes, sir.
Okay, so please keep that in mind forever, right, dear?
Yes, sir.
Yes, sir.
Okay, now with that being at the hindsight, let us go for the next part of static fluid equation, and that being write down. A movable rod. Given a movable rod, which is hinged at the bottom, given a movable rod which is hinged at the bottom, find level of water, find level of water for the gate shown, to open. Find level of water for the gate shown to open. Now let it be explained first. What is it there? It's a rod. Is it okay?
Yes, sir.
You can assume it to be manifestation of wall. No issue. Is it okay?
Yes, sir.
And there
Yes, sir.
wall. And wall is hinged over here. And wall is maintained by a spring constant K here. Is it okay?
Yes, sir.
Yes, sir.
So as you fill water, this is the wall I'm talking of. As I'm filling water, what is happening to wall owing to water occupancy? It is being subjected to a force. Agreed?
Yes, sir.
Yes, sir.
Okay. And the point of application of force, you know now, will change with height, right? Yeah.
Yes, sir.
Yes, sir.
So point of application is continuously changing. If point of application is changing, then from hinge, as that is a point where it is hinged, the wall is hinged or the rod is hinged. From hinge, the point of application of force is going further and further.
Yeah.
Yes, sir.
So, torque which wall is subjected to is perpetually increasing.
Yes, sir.
Yes, sir.
Yes or no? Excuse me.
Yes,
Torque that the rod is or the wall is subjected to is increasing with rise of water in it. Correct? Yeah? Yes or no?
Yes,
Yes,
sir.
sir.
Now what will happen? That torque till the time this spring is able to balance, till the time the torque is balanced by spring, wall will not move, correct?
Yes, sir.
Yes, sir.
The force which correspond to torque, and torque in which sense you know that very well, correct?
Yes, sir.
Yes, sir.
If the torque is high, then what will happen? This will start leaning to the left, right?
Yes, sir.
yes, sir.
Fall leans to the left means the passage over here will fall open. Is it okay? If there's a passage over here, then this passage will fall open. This one not here. Here, then what will happen to this passage? This passage will fall open, water will seep. Correct here?
Yes, sir.
Yes, sir.
So this question is based on the rotational aspect. We are moving from force to torque. Clear here?
Yes, sir.
From force to torque now. Tell me if I want to know the height up to which safe operation is possible. By safe operation, what I mean, there should not be any seepage allowed here. Correct, yeah?
Yes, sir.
And what shall we say? We shall say that whatever will the spring provide as torque, should be the maximum to which water should rise to hold. Correct, yeah? Correct or not?
Yes.
Yes, sir.
And as the water is rising, what it is doing to the wall. Tell me first, okay, fine. Let me ask you, keeping it in solo. How will you calculate torque due to water rise? How will you calculate torque due to water rise? What you'll have to find for torque? Two, one the force, the other perpendicular distance, right?
Right,
Yeah,
sir.
yes.
There are two findings. One the force, the other perpendicular distance. What will be force at any point that we can get easily? Tell me, how can you get easily? Height is h. What will be force equation? Just now we read P naught
Not
plus
plus rho.
2 h by 2, correct, yeah? P naught plus rho g h by 2 into h into L, right?
Oh, yes, sir.
Just now we wrote, right, yeah?
Yes, sir.
Yes,
What
sir.
is this? This is force to us, correct? Force
Yes,
to
sir.
us. Where? Force where? Please be careful of the edge. I'm changing edge for your convenience because this edge I have already marked. And the edge that I have written over here should be from the free surface, correct?
Yes, sir.
Yes,
So
sir.
this is H prime to us. Distinguish. Please make the distinction between H and H prime. Fine, all of you?
Yes,
Yes,
sir.
sir.
Okay, so this is what we get pressure at depth h and multiplied with h prime and L, we get the force at depth h. Force should be multiplied with
Area.
perpendicular distance.
Okay.
Perpendicular distance from where? From point of calculation. And what is my point of calculation? Surface or hinge?
Yes, sir.
What is my point of calculation? From where shall I calculate torque? Hinge or surface? From where the bending is to be done? Hinge or surface? Tell me, dear.
Hinge.
Sir, hinge.
So, what shall I multiply this force with? This force should be multiplied with perpendicular distance. And perpendicular distance will be h minus h prime. Agreed?
Yes, sir.
Got it or not? Please be very careful what I'm doing over here. Please distinguish h from h prime. Getting it, Krish? Krish?
Yes, sir. Hello.
Are you getting it, Krish?
Yes, sir. Yes, sir.
Okay. So this is the height. What we did? We calculated torque, didn't we? Did we calculate torque?
Yes, sir. Yes, sir.
Torque about hinge, right?
Yes, sir.
Yes, sir.
Torque about hinge. Why so malignly you are responding to my question, Krish?
No, sir. I'm not feeling that well, sir. I'm. Yes, sir.
This torque you didn't get.
No, sir. I'm not feeling that well. That's why I'm responding low.
Oh, what happened?
No, sir. I got a small cold.
Okay, fine. Okay, sir. So this is what you are getting as the torque equation. Torque about the hinge point. And this, if I am to take totality into consideration, should be integrated from where to where? Now, please see for yourself. Be very careful about it. You have calculated force, correct?
Yeah.
Force where?
Yes, sir.
Force, this force acts at which point? That also you know. This is the force and this force. Let me take in the bracket first. This is force to us, correct?
Yes,
Yes,
sir.
sir.
And force should be multiplied with what? Perpendicular distance,
Perpendicular
correct?
distance.
To get
Yes,
torque.
sir.
Yes, sir.
Force with perpendicular distance and I get torque, correct?
Yes, sir.
So
Yes,
I
sir.
get torque on what? I get torque on the wall, correct?
Yes, sir.
Yes, sir.
But I have landed you into a problem, and that is what I wanted to highlight. Few derivations that you do, and be very careful about fluid in particular. Few derivations which you do, and in SHM, which is also into coming. Few derivations which you do. If you apply your rephrasing to the answer, as I did in the previous case, what did I tell you? That if I am to find force on wall, what I can do, I can find pressure at midpoint and multiply with total area. That was my brainchild, correct?
Yes, sir.
Yes.
Yes, sir.
That is what it did shape to, correct?
Yes, sir.
Yeah.
Yes, sir.
But if you are of the opinion and keeping a blanket perception that now you can assume that whenever a question is given to you, force position if is being asked, then you will say that force will act only at the midpoint. Will you be right?
No.
Will you be right
No.
in your figment that force will act on the wall only at the midpoint?
So that's
No,
a
sir.
wrong conception.
Yes, got there. But this holds good. Till what time? Till the time someone is asking you question which is limited to force. Agreed?
Yes,
If
sir.
the person
Yes,
has
sir.
not asked you on where it applies, but has asked you on what is the total force. Getting it there?
Yes.
Yes, sir.
Yes, sir.
If the person is applied, what is ask you question on what is the total force? Then you are comfortable in your skin to say, okay, what is the height? P naught, H height, so P naught plus rho G H by 2 multiplied with area. This is the force. But if the same person now asks, where acts it? If the same person now asks, are you getting it? Where
Yes, sir.
acts this force? You are in a fix. Tell me why? Why you are in a fix? Because then this equation is not to come to your rescue. Why? And a usual organic answer will be midpoint. And you know very well, you are not correct on that. It is not only midpoint of the wall on which force will act. Correct? Yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
Please be very careful of what we do infer from answers. And this we will keep always on. In SHM, all the more is to be seen. Time period will remain same, amplitude will change. So there are much into coming. That is what I want to get you an inkling on. So when you are into deriving something, please limit it to, because every formula comes with a limit. Correct? Yeah.
Yes, sir.
Yes, sir.
Yes,
So
sir.
here what will I do now? Now if I take P naught plus rho G H prime by 2 into H by L, what is this to us? This is to us force. We wrote force. But do I know where the force will act?
No, sir.
No, sir.
Where this force will act? I don't know where the force will act. And if I was of the opinion that it will act midways, then you know that I'm wrong. So what shall we do? What shall we do then? We will have to start from scratch. And what that? We'll have to multiply pressure. What we did then? Can you recollect? Can you recollect what we did then? P naught plus rho GH was multiplied with DH into L. Can you recollect?
Yes,
Sir.
sir.
So P naught plus rho GH prime over here will be multiplied with L into DH prime. Agreed?
Yes, sir.
What will this get you? This will get you force. Force on what line? You know that very well, correct?
Yes, sir.
Yes, sir.
And that line is at what distance from the hinge position? Perpendicular distance h minus h prime. Got it there?
Yeah. Yes, sir.
Yes, sir.
Yes,
H
sir.
minus h prime. Getting it or not? This is the force equation. And force multiplied with perpendicular distance of operation. Perpendicular calculated from the hinge position. What is that perpendicular? H minus h prime. Getting it?
Yes, sir.
Yes, sir.
Yes,
And
sir.
then we will do to this. This will be integrated from where to where? This will be integrated from where to where? Now h prime is the variable. So from 0 to h. Agreed?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah, getting it or not? Tell me all of you. Vedant,
Yes,
getting it
sir.
or not? Why
Yes,
do I
sir.
have to take a break, a pause? Is that clear? That is apparent over here. And I want to assert on this point. Are you getting it?
Yes, sir.
Yes, sir.
Blanket perceptions we do generate without of they being a mention. We, as we are coming from something which is our figment of imagination, we take it to be a blanket perception call. That should not be the case. Correct, dear?
Yes,
Yes, sir.
So when it is to force, we know, but when it is to torque, and that was the question which Krish did ask. When it is to torque, then we need to start from scratch. Right, dear?
Yes, sir.
yes,
Yes, sir.
Okay, so this we will do. And when will it be balanced? Till what length it is to be balanced? See, this will get you torque due to rise of water until the time this torque is equal to K into X. When will it open? When there is some value of X, correct? As of
Yes,
now,
sir.
it is its natural length. Are you getting it?
Yes, sir.
yes,
Then
sir.
if you will increase the length by X, if you will deform it, correct, dear? If you will deform
Yes.
it, then what will be the force here? K into X, K into X, correct?
Yes, sir.
Yes, sir.
K into X will get you what torque? K into X multiplied with capital H, correct?
Yes, sir.
Yes, sir.
What is K into X? And capital H is the height, right, dear?
Yes,
sir.
sir.
Yes, sir.
So, when till what time it will be balanced? Till the time this is equal to this, correct?
Oh, yes,
Yeah.
sir.
Okay, so from here we get the torque equilibrium as well. If torque is in equilibrium, they can ask you. See, there are different ways in which it can be articulated. Let's say it's given to you what x is allowed, what k, and what h. Then they can ask you h prime. Getting it?
Yes, sir.
Yes,
And if h prime is the maximum height given to you, x is given to x, means the vent over here. Are you getting it? The fissure over here. Is it okay?
Yes.
Fissure is of what dimension? X. Is it okay?
Yes, sir.
And we don't take in general because pressure is very small. So you know very well that spring can also reorient. Correct, dear? Spring will
Yes, sir.
also reorient, of course, but we don't take into account the reorientation of spring, assuming fissure to be negligibly small. Am I clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, because then the other element will come into account. So just to keep ourselves safe of the other element, spare ourselves from the other element, what we do, we keep the fissure very small, and accordingly, if is asked what will be the fissure length for the seepage of water, the rest being given, you are in a position to calculate, right, dear?
Yes, sir.
yes, sir.
These questions are asked here, and I will also be asking these questions to you. What they will get you, they will get you a tumbler, and then they will get you a small fissure in the tumbler. Okay, water is filled. Dimension of tumbler will be given to you. Is it okay? And then they will ask, calculate torque about this point on the tumbler, on the fissure. Is it okay?
Yeah, yes, sir.
Yes, sir.
Yes, sir.
Over here, so they will ask you what is the force on this part, this stuff. Will it be safe to operate up to certain height or will it open? Getting it?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, those questions can be very well be asked. Okay, now moving on to the other part. Write down. There is an orifice at the bottom. There is an orifice at the bottom of vessel taken. There is an orifice at the bottom of the vessel taken. Can we apply equation of can we apply equation of static pressure to find pressure at the orifice? To find pressure at the orifice. You want to find pressure at the orifice, P A, make it P small a, and P naught atmospheric pressure is given to you. Can we say PA is equal to P naught plus rho GH is the question? Yes or no? There is an orifice, there is a small escape, very narrow escape for water or fluid in it. Can we use static pressure equation?
So does water flow through it?
Yes, dear?
So water flow through it?
Yeah, water will flow out of it. Can we use static pressure equation? Again, dear, you all are not into revising. That will not lead anywhere. Let me tell you. Let me talk Turkey. Because revision is important. I have told you first things first. You need to revise. How did we get T is equal to P naught plus rho GH? When you took equilibrium of this water table, right?
Yes,
Yes,
sir.
sir.
Remember, we took equilibrium of this water table. And then we got to the result. P is equal to P naught plus rho GH. Correct, yeah?
Here
Yes,
you
sir.
cannot use static pressure because H will continuously vary.
Why? Because it is moving down. Correct, yeah?
Yes, sir.
Yes, sir.
Moving down. So of course we cannot go with static pressure equation. Are you getting it?
Yes, sir.
Yes,
Now
sir.
let me ask you then, with this at the backdrop, let me ask you, if river flows and is flowing in the horizontal direction, river, and we move into the river, perpendicularly into the river. Are you getting it? That is perpendicular to flow. Getting it?
Yes, sir.
Yes, sir.
Can we use pressure equation or not? Static pressure equation or not? Yes or no? It is flowing over there as well, Krish. As water will flow in this case, you have positioned your answer on flow of water, right, Krish?
Yes, sir.
So let me scratch a bit more on that. Let me needle you on that. If water is flowing and flowing is what the consideration is, then water flows in river as well. Correct, yeah?
So, but in this case, height is constant, no, sir? So,
It's also okay. You have meant that if the height is constant, it's fine. So let me pour water to maintain height. I'm pouring water in. I'm maintaining height. Then
but you still can't use because water is flowing.
okay,
Sir,
I place this argument again. Water is flowing in river as well, right? Yeah.
Yes, sir.
So there also I may not be in a position to use it. Don't get cagey. Whatever you are having, use do say accordingly. Use your own faculties. Okay, I'll try to dissuade you, of course. That is par for the course because I need to get that solidified, cemented with you. Yes, dear. What flow is the contention? You said which we have maintained, the level also maintained. Then being asked in the same fervor, taking cue from here, can you apply the same to river? And can you then say uses of static pressure equation in river is also not possible?
so we can say that.
Not possible. Okay. Now, what was the
So once
predicament over here? Can you tell me the Achilles heel? Can you quantificate? The Achilles heel being this water table was moving down, right?
yes,
Yes,
sir.
sir.
Yes, sir.
Maintaining the level, but one that you have taken for your study is to move down, right?
Yes, sir.
Yes, sir.
So this water table is not in vertical equilibrium, correct?
Yes, sir.
Yes, sir.
The river is flowing in which direction? This direction, correct?
Yes, sir.
Yes, sir.
And this direction I don't have any trucks with. Reason? I'm not moving in this direction. Which
Yeah.
direction I was moving it? I say I'm moving perpendicularly down towards the
Down.
bottom of river, correct?
Yes, sir.
Perpendicular
Yes,
to
sir.
flow, correct?
Yes, sir.
Yes, sir.
So if it moves in this direction, maintaining its vertical equilibrium, I can very well use this pressure equation, correct? Yeah.
Yes,
Because
sir.
Yes, sir.
my equation is golden by vertical equilibrium. Getting it? Getting it or no?
Yes,
Yeah,
sir.
yes, sir.
These are the used questions in IUDO. So please get a clear idea on these. If river is flowing and someone is asking you, what the pressure over here at height h, then you can unflinchingly say it will be P naught plus rho GH. Got it?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, then the person will ask, how can you use static equation? This is a case of flow of water, correct? In the same breath, the person is to ask you, rebuke you, correct?
Yes,
Yes.
sir.
Yes, sir.
What will be your answer to buttress your argument? To buttress your argument, what will be your answer? Come on, speak in so many words, all of you. What will
Sir,
you
this,
say?
So because we are flowing perpendicular to the flow of river, we are
Because
flowing
we are
vertically.
moving perpendicular to
Yeah,
flow
we
of
are
river, correct?
moving. Yeah.
Yes,
Because
Yes,
sir.
sir. I'm moving.
perpendicular to flow of river, our concern being perpendicular to flow of water, correct?
Yes,
Yes.
sir.
yes, sir.
In every case, hitherto, in every case, if you are moving perpendicular to flow, you are qualified to use your pressure, static pressure equation. Am I clear?
Yes,
Yes,
sir.
sir.
Very good. Okay, next, write down.
So, but one small question. So, what will be the pressure in this case? So, at the orifice?
Yeah, at this point, it'll
Yeah,
be
yes,
equal to atmospheric pressure. It is open to atmosphere, na? P naught.
sir. Yes, sir.
It is open to atmosphere, right? Yeah.
Yes, sir. Yes, sir.
This was a no-brainer, by the way, but I want to make my point very clear that you can use it or not. So my question was not position of what the pressure over here. I was asking you a question on whether we qualify uses of static pressure equation or not. Correct? Yeah.
Yes, sir.
We will reveal more on this, but when flow is taken. For now,
Yes,
it is to be kept at PA will be equal to P naught. Why? So it is open to atmosphere. Correct?
yes, sir.
Okay. Now right. As water flows, as water flows in a narrow tube, as water flows in a narrow tube, velocity of water table, velocity of water table is function of position. Velocity of water table is function of position. That is, now be very careful, class, over here. The first and the paramount, the prerequisite is tube is narrow. I'm showing it with much larger dimension, but you are coming from an understanding. And what is that, dear? What understanding you are coming from? Tube is narrow. Is it okay?
Yes, sir.
Yes, sir.
Now water is flowing in it. Why is tube narrow? If someone is to ask, you will tell him or her that you want every portion of tube to have an occupancy. Is it okay?
Yes, sir.
Tube
Yes,
is
sir.
taken broad. Think of the broad pipe that you have for garbage flow. You cannot say that garbage is evenly flowing in it. Correct, dear? Why? Because the lower segment will see more of flow than the upper segment. Agreed or not?
Yes, sir.
Yes, sir.
You can do away with this if you have taken a narrow, very narrow tube, right, dear?
Sir.
Yes, sir.
Yes, sir.
Our aim is complete full throttle occupancy of narrow tube. Clear, dear?
Yes, sir.
Yes, sir.
And that we can achieve if and only if the tube is narrow, goes without saying. Say me yes or no.
Yes,
Yes, sir.
sir.
So the prerequisite being tube is narrow and it is fully occupied with water. There is no void anywhere. And water is in perennial flow. Is it okay? Is it
Yes.
okay?
Yes, sir.
Water is flowing and flowing into it perennially. Fine, no issue. Now, here there is a particle of water. Can you see that?
Yes, sir.
Yes, sir.
Here there is a particle of water. And I wanted to calculate at equal to 0 I wanted to calculate what is velocity of this particle. Got it, yeah?
Yes, sir.
So I had a gadget. With the help of device, I calculated and marked the velocity as v. Find, yeah?
Yes, sir.
Yes.
Yes,
I
sir.
asked one of my friend as well to calculate velocity of particle at his position. His position being this. So he marked the velocity as Vb at same time. Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
After some time, what is to happen? Particle B will take position of A. Agreed or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
Particle B will take position of A. Now, when particle B will take position of A, then there can be two situations which you are to contemplate on. Two situations, contemplating tea leaves, as we say. So, two situations you are contemplating on. What are the possibility? The possible which you are to get as an observation being B will have same velocity as A. He will have same velocity. What was when A to claim? Agreed or not? That can be one situation. Say me yes or no.
Yes,
Yes,
sir.
sir.
So B will read even with what when A there. Correct? Yeah. Of course, B is not reaching at t equal to 0. T equal to 0 it was here, right? Yeah.
Yes,
Yes,
sir.
sir.
So B makes an appearance at t equal to t1 and B is seen to, I'll write that down. But t equal to t1, you are to see B here, or t prime, you are to see B here. And here, by the way, I should not mind that. Here only, correct? Yeah, here only. Are you getting it?
Yes, sir.
Yes, sir.
T equal to t prime, you see B here. And where must be A? Somewhere here, isn't it here?
Yes, sir.
Yes, sir.
Okay, so t prime at t equal to t prime, B claims the position of A at t equal to 0. Agreed?
Yes,
Yes,
sir.
sir.
At t equal to t prime, B claims the position of A at t equal to 0. Now, when B is claiming the position of A, then there are two possibilities. One, it will have the same velocity as that of A when A was occupying that point, right here?
Yes, sir.
Yes,
Or
sir.
it can have a different value, right?
Yes, sir.
Yes, sir.
Getting it here? It can
Yes.
either
Yes.
have the same value what A had when present at that point at t equal to 0. That means what the preceding particle did at that time have will be have now. Agreed?
Yes, sir.
Yes, sir.
Yes, sir.
The other case, it can have completely different values. If B is to have the same value as that of A when A was occupying that position, then this motion can be said to be function of position. Agreed?
Yes, sir.
Yes, sir.
If B is to have same velocity as that of A when A was at that position which happened at t equal to 0 and with B it is happening at t equal to t prime, then we can say that velocity inside of the tube is function of position. Agreed or not?
Yes,
sir.
sir.
Agreed, sir.
Material, which particle is coming and occupying which place? Are you getting it? It is immaterial. After some time, what will happen? B will flow and C will come, correct?
Yes,
C will
Yes,
occupy
sir.
that place. But C, when coming to that place, it comes with a rider. It will be allowed to occupy that space, that point, if and only if it is in adherence to the precedent set, correct?
Yes, sir.
yes,
The
sir.
violative of the precedent set, that it will not be able to occupy that position. Say me yes or no?
Yes, sir.
So
Yes,
if
sir.
it is in adherence to the principle set, the precedent set, then the motion can be said to be function of position. And when motion is function of position, or to be precise, speed is function of position, we call this motion, we call this flow streamline flow. Am I clear?
Yes, sir.
This is called streamline flow. You have streamlined it. Are you getting it? Yeah. I have to streamline means what? I have to let the system get established. so that whosoever is coming and occupying the space, that person is acquainted to what duty is being assigned to the presider and accordingly will execute his duties. Correct, dear?
Sir.
Yes,
That's
sir.
what is called streamlining. Correct, dear? Say me yes or no?
Yes, sir.
Yes, sir.
It is being streamlined. It is being streamlined. This motion is called streamline motion. If not, if B is violative, it'll be random motion. Are you getting it? If B is violative, B says that no, I'm not to be in the way that other did, taking it like down. I
So
have
I
my
did not
rights.
understand the
Yes, dear.
streamline motions.
Streamline what?
The streamline motion, sir. Could you just explain it once again?
Streamline means just in a nutshell, what is streamline? Velocity being function of position. Velocity being the function of position. And when I say velocity being function of position, every point has got a velocity defined to it. This point, any point you take, they have a velocity to their merit. By velocity to their merit, what I mean, whichever particle are to come over here, they will have to but come to terms with velocity. Is it okay?
Yes, sir.
They will have to come to terms with velocity means they will have to accept the order set. And who has set the order? Who has set the order? The order being set by the predecessors. Can we say that?
Yes, sir.
So there has already been an order set to it. 5 meters per second. Now comes C, comes D, comes E, F, whichever particle, one particle cannot remain there for long because the case of flow. So the particle will not remain for long. Particles are to keep changing their position incessantly. But wherever the particle is to go or whichever position the particle is to apply, it should be in adherence to what is being followed, what is being the rule of, or as we say, what is being the law of land. Is it okay?
Yes, sir.
Yes, sir.
And what is the law of this part of land? That you need to move and move with what velocity? Known to you. Are you getting it?
Yeah.
Yes, sir.
If you are there, you need to be in adherence to the law of land. Am I clear?
Yes, sir.
Yes, sir.
And if you are violative, then you will not be partaking. This motion will no more be streamlined. It will be called a random motion.
Okay, understood, sir.
Okay. So in a way, every position has a velocity registered to its merit. Can we say that?
Yes, sir.
Yes, sir.
Yes, sir.
So velocity is function of position. Can we say that?
Yes, sir.
Yes, sir.
Okay. And this motion will then be called streamline motion. You can join the dots right here.
Yes, sir.
Join the
Yes,
dots
sir.
and see for yourself. No line will intermingle. Getting it? See for yourself, please. Lines are not to intermingle. Why? Because it's being decided in which direction they are to move. Right here.
Yes, sir.
Yes.
Yes, sir.
Not intersect with this line. This line will not intersect with this line. So there are myriads of lines that you can draw. Say me yes or no, dear.
Yes, sir.
Yes, sir.
They are all in a way manifestation of streamline motion. Can we say? See for yourself. Okay.
Yes, sir. Yes,
Yes,
sir.
sir.
That's the reason we call it streamline. You can draw one curve to represent entire of the tube. Agreed?
Yes,
Yes,
sir.
sir.
Okay, we can just present it by one curve, right? Yeah.
Yes,
In
sir.
random motion, do the lines intersect?
Yes, clear? Yes, yeah.
So in random motion, do the lines intersect?
Yeah. It will. It will. And that can change as well. You don't know. You cannot predict. It's random, right here.
Yeah.
Okay. So there they will intersect and they will change with time as well. Here there is no intersection. Only streamline motion can be represented by lines. Is it okay?
Yes, sir.
Okay. And they are not to intersect each other. So is the concept of streamline motion first clear?
Yes, sir.
Yes, sir.
Okay, so this is what is called a streamline motion. As you know, they will be using only the words. So you should be clear on what streamline motion is. It is a motion in which velocity is predefined. Can we say that? And its
Yes,
function
sir.
of position, fine?
Yes, sir.
Yes, sir.
Having said that, now, if I take a regular cross section, that means a cross section which is not changing, cross section which is fixed. Then can we say that every dot, now please be very careful now, as questions are into coming on this. Can we say that every dot which we join to get a line, every dot which we join to get a line, and this line is perpendicular to the flow of liquid. Find here.
Yes, sir.
Yes, sir.
This line is
Yes, sir.
perpendicular to the flow of liquid. Got it here?
Yes, sir.
Can we say that these lines, points on these lines, are all to move with same velocity, thereby referring this line with one velocity? Yes or no?
Yes, sir.
Yes, sir.
And if this line is moving with velocity v, then this also is to move with velocity v. Can we say that? Think about it. Yes or no?
Yes, sir.
With
Yeah.
v, then this will
So we can
also
say,
have to move with v. Can we say that? Area of cross section, mind you, I have taken say.
Yes, sir.
yes, sir.
What makes you say so?
So,
Sir,
What
if they
makes
have
you say
different,
just to it?
sir, if they
There must
have
be some
different,
reason you accepted it, correct, dear? Ah, yes, Krish, you are saying something.
have different velocities.
Yes, Krish, you are saying something.
1 second, sir. 1 second. I got disconnected.
Okay. They are in agreement with this V will equate with this V. Area of cross section we have taken same initially, but they are not able to reason it out. So
Sir,
if you can clear the
Yes.
air.
Sir, if velocity is different, so it won't be streamline flow anymore, no, sir.
Why?
So because if one
No,
is
no, no,
moving,
no. Please be. If velocity is different, I didn't say velocity same. Please don't read me wrong. I didn't say velocity same. I said this is VA and this is VB, right there.
yes, sir,
oh,
yeah.
I didn't say velocity same. How can I say velocity will be same? That means too much of an ask. I said that as you are moving, whatever is the velocity of this point is to itself fixed. That means particle will change their position, but whichever particle come and occupy this position, they are bound to be in adherence to the law of land, I said. Correct, yeah?
Yes, sir,
yes,
yeah.
sir.
Okay, so all are not uniform. This has got a different set of laws. Getting it?
Okay.
So they will keep on changing. That I didn't say. So if you are in agreement, then you'll have to cite some other example. I didn't say that this is VA, this is also VA, this is also VA, this is also VA. That I didn't say.
Oh,
I said that this is VA, this can be VB, this can be VC, this can be VD. And then I asked that on this line, every point will be moving with same velocity or not. And if they are to move with same velocity, can I say this line is moving with the same velocity as this line? These were the questions asked.
okay.
Is
So
it
the
okay, Krish?
velocity is in same.
Firstly, okay, fine, I go back. This particle, this particle, this particle, this particle, this particle. Okay, 1, 2, 3, 4, 5. Are you in agreement that they are to move with same velocity? Yes or no? It is a streamline flow.
Yeah.
Yeah,
Streamline,
Yes,
it's
sir.
a
Yeah.
function of position. Yeah.
streamline flow, cross section is uniform. Am I clear, Presh?
Yes.
Yes, sir, yes, sir.
Siddhant?
Yes, sir.
Please very minutely discuss this point because you don't have a question to ask, you have to take it today itself in the class. Streamline means what? Try to understand that concept. You will not be getting anywhere, mind you. That's the reason, and that's the reason you ask any student about the question which is into coming. They are bound to go wrong on that. Streamline means what? You know this. Now my question. area of cross section is A, which is constant. Find here.
Yes,
Yes, sir.
5 particles I take on a line. On a line which is 90 degree to flow of liquid. Find here.
Yes, sir.
Yes,
Yeah.
sir.
Yes, sir.
These 5 particles, are they to move with same velocity? Is the question asked.
So not the two lines.
So I am asking first on particle. I'll come to line later.
Okay.
You have answered on line. I said I'm going back to and asking you in piecemeals. First on this line, the particles which are there, are they to move with same velocity or they can have different velocity? That is being asked. Can they have different velocity or they are to move with same velocity? A question being asked. It is a streamline flow.
So velocity must not be same. They can be
Velocity
different.
is same. Okay, why so?
So velocity in streamline motion, velocity is the function of position.
It is
Not
true.
so.
Okay,
So
so
it's not.
different positions, so we should get different velocity. You're coming from that thought process, right, Vedant?
Yes, sir.
Okay, I'll lay credence to it. Yes, Adesh, what you have to say?
Yeah, sir, I agree with him. All of them are at different positions.
Okay, so velocity must be different, correct, yeah?
Yes, sir.
Okay, fine. Krish?
Sir, I guess velocity is same.
Okay, you are going with velocity being same, and what's the reason for your take?
So because it's all symmetric.
It
Everything is
is
symmetric.
symmetry. Okay, symmetry. Okay, fine. Now, 2 cases over here. When you take a segment, then you are oblivion to source and sink. Remember that. That means you are remote from source and you are remote from sink. Getting it?
Yes,
You
sir.
don't know. You don't have. You're completely ignoramus. Completely ignoramus. You are novice about source position and sink position. Are you getting it?
Yes, sir.
It or
Yes,
not?
sir.
That means you don't know where is tap and you don't know water will get, which place water will get a vent. Clear, dear?
Yes, sir.
Yes.
Okay. Now, if you have a tap here, let us see. If you have a tap here and that tap has got non-uniform flow of water, are you getting it? That means tap is sending more water to this and less to this and then more to this. Is it okay?
Yes, sir.
Yes, sir.
Then it will be maintained through and through. Are you getting it?
Yes, sir.
It
Yes,
should
sir.
be maintained through and through. Getting it or not? Why?
Yeah,
Yes.
yes.
Why is this to be maintained through and through? Because liquid is incompressible. Given
Yeah, yes,
volume,
sir.
whatever mass enters, that mass in the same time should leave, right? Yeah.
Yes, sir.
Yes, sir.
Because volume is fixed. And if you tweak mass, then you're tweaking density. Correct?
Yes, sir.
Correct or not?
Yes,
Volume
sir.
is given. If you change mass, if you tweak mass, you say that now there is more mass inside of this volume. Then what are you doing to density? You are changing density of liquid. Say me yes or no?
Yes,
Yes,
sir.
sir.
Which is not allowed. Reason? It is incompressible. Correct, yeah?
Yes, sir.
Yes.
Okay, yeah.
So mass enters in time dt. The same mass is bound to leave the other segment in time dt. Agreed?
Yes, sir.
Yes, sir.
So if water is being thrusted and you are thrusting here more, then this point, then what will happen? Taking that velocity, it is to come out here more, here less, and here more. Correct, yeah?
Yes, sir.
Yes,
Yes,
sir.
sir.
To maintain our take on incompressibility. Correct, yeah?
Yes,
Yes,
sir.
sir.
Yes.
But what did I tell you? We generally take source to be very remote placed. Correct.
Yes, sir.
Yes.
Yes,
And
sir.
sink also to be very remote placed. Correct.
Yes, sir.
Yes, sir.
Yes, sir.
So So when source is remote and sink is also remote, then you will recollect how you used to show the parallel lines, because energy what you will be getting cannot be different. It has traveled a very large distance. So energy will become even. And what you can then say, if not given.
Sir, I cannot see you.
So your
Sir
video
is
is
on
off.
There was a call. What did I say? I was telling that if the source is remote, which we always do take, otherwise it will be mentioned that source is nearby, which will never happen. If source is remote and so is sink, getting it?
Yes, sir.
Yes,
Then we can say that whatever velocity this is moving with this point will move this point, will move this point, will move this point, will move this point. Clear?
Yes, sir.
yes,
Though
sir.
the position being different. Though their position being different. So I am not making over here any exception. It can be different. And it is very well different shown over here as an example right here. But in that example, what we have taken to be as an exception, we have taken it to be as an exception, tap being very near. Correct here?
Yes, sir.
Yes,
Yes,
sir.
sir.
Is very off, very far off, far flung from this position, then we are correct in our assumption. What assumption? Our assumption that this point, this point, this point, this point, and this point, they are all to move with same speed. Clear?
Yes, sir.
Yes, sir.
So, in more cases than one, please write it down. In more cases than one, a line which is perpendicular to flow, a line which is perpendicular to flow relates to one velocity. Clear, dear?
Yes, sir.
Clear, dear, all of you?
Yes,
Yes,
sir.
sir.
Please check it with the certain precision that we have come to, because you can be on this point fixed. Is it so? Always so? May so? Right, dear?
Yes, sir.
Yes, sir.
I think that point is clear now, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
And going by our understanding of whatever volume or mass is entering, the same mass is to leave, correct?
Yes, sir.
Yes, sir.
Yes, sir.
But you can say whatever is velocity of this point, area of cross section the same, mind you. Is it okay?
Yeah. Yes, sir.
Yes,
Yes,
sir.
sir.
Area of cross section same. Now focus only on this part. Is it okay? Focus only on this part. Am I clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
What mass entered? V delta T into rho into area. Agree?
Yes, sir.
Delta T time. Velocity is V, delta T, V into delta T length, length multiplied with area volume, volume multiplied with rho mass. Is it okay?
Yes, sir.
Yes,
Yes.
sir.
Mass entered the hash portion, same yes or not, yeah?
Yes,
Yes,
sir.
sir.
The same mass should leave.
Yeah.
Yes, sir.
Yes, sir.
Yeah.
Otherwise, this volume, not the total volume, otherwise this volume will see a change in density, right? Yeah, same yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Not allowed. Which is not allowed, which we don't approve of, correct?
Yes, sir.
Yeah, yes,
Yes,
sir.
sir.
Same mass should leave. That means rho the same. V I don't know, V prime I take, delta T the same, area the same, correct?
Yes, sir.
Yes, sir.
Correct, same yes or no?
Yes,
Yes,
sir.
sir.
What do we get? V and V prime related by? Quickly.
V is equal to V prime.
Yes, V is equal to V prime. Getting it here?
Yes,
Getting
sir.
it here, all
Yes,
of you?
sir.
V
Yes,
is
sir.
equal to V prime. This is what you get when you have uniform cross section, correct?
Okay, yeah.
Yes, sir.
Okay, now let me take a non-uniform cross section and ask you. This is a non-uniform cross section. Find here. What is the area over here? Area over here. This is S and this is S1. Let me mark this velocity as V1 and this velocity as V2. Firstly, all the particles can I again assume will be at same velocity? I told you generally we do. Can we assume all the particle on this line will be moving with velocity V1? Yes or no? Do I
Yes, sir.
have
Yes,
you
sir.
on the page? Tell the proof of pudding
Yes,
lies in
sir.
eating. Yes or no?
Yes, sir.
Yes, sir.
Okay, and on this one, here also, all the particles are moving with velocity v2, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
Can I still be of the opinion v1 will be equal to v2 as we got in this case?
No, sir.
Yes, sir.
No, sir. No.
Because it's not cement. Because the
Yes.
bo
Yeah, tell me, Adesh.
Sir, we cannot because the body is not uniform.
Exactly. So now in this volume, what mass enters? Rho A1, B1, delta T, correct?
Yes,
Yes, sir.
sir.
And what should leave this one is rho A2, V2, delta T in delta T time, correct?
Yes, sir.
Yes, sir.
Yes, sir.
And we know that we cannot compromise on incompressibility, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
So this should be equal to this, agreed or not?
Yes, sir.
Yes, sir.
What do we get from here? Read it. Read it aloud.
A1 V1 is equal to A2
1
V2.
is equal to A2 V2.
A1 V1 is equal to A2 V2, correct?
Yes, sir.
Check Adesh, is not?
It's correct.
A1 V1 is equal to A2
A2
V2. What
V2.
is this called? Equation of continuity. This is called equation of continuity, which is based on incompressible nature of liquid, or we can say conservation of mass. Is it okay?
Yes, sir.
Whatever mass enters must leave. What do we get is a very important relation, by the way. A1 B1 is equal to A2 B2.
Yes, sir.
Yeah.
Understood.
Yes, sir.
Yes, sir.
Okay, what's the time?
2, 4.
5.
Yeah.
When did we start?
12:30.
Okay, fine. So A1 B1 is equal to A2 B2. One equation done with. Correct, dear? Equation of continuity, right? Next. Let us take a narrow tube. Let us take a narrow tube bent in the form of sector of a circle. Bent in the form of sector of a circle. If a streamline flow is maintained, and 1, 2, 3, 4, and 5, and 1, 2, 3, 4, and 5 particles enter at t equal to 0.
So I think your screen is frozen.
Okay, just
No.
1, 2, 3, 4, and 5. Is it?
No,
No,
sir.
sir.
Oh, must be my problem. 1 second. I'll leave and join.
1, 2, 3, 4, and 5 particles enter at what time, dear? They enter at the same time
Yes.
t naught. Is it okay? Is it okay, class?
Yes, sir.
Yes, sir.
Okay. So they enter at the same time. Particle 1 will come out first. Particle 3 will come out first. Particle 5 will come out first. They will come out at the same time. They will come out at the same time. Where is the arrangement kept here? On a horizontal floor, right here?
Yes,
Did I
sir.
tell you
Right.
that? Did I tell you that?
No,
Horizontal
no, sir.
arrangement?
No.
No,
No,
sir.
sir.
Okay, just Make that this point clear. Make that this point clear. It is a horizontal arrangement. Okay. The tube is kept on a horizontal ground or table, and 1, 2, 3, 4, 5 enter. Now, what according to you should be the situation? Will they come out also at the same time, or they should come out at different times? Given to you, that
So
is a
when you
streamline
say,
flow. Okay, what is given to you? The flow is streamlined. Got it? Yeah.
sir, I have
Yes.
a doubt.
Tell me.
So when you say the tube is kept on a horizontal ground, do you meaning all the, or do you mean all the particles at any point of time are flowing perpendicular to the direction of gravity? Like that, do you mean?
Yeah, yeah. I am
Okay,
saying that
like that.
exactly that. But the tube is narrow, so you are not to think of P is equal to P naught plus rho GH. There is no H that you have to associate. Correct? Yeah.
Yes, sir.
Yeah, yes, sir.
This is a streamline. This is a different segment. We are placing or positioning our question on a streamline flow, understanding of streamline flow. This is one of the part of question from IRUDO. Tell me, dear. 1, 2, 3, 4, 5 enters. And it is a streamline flow. So what is your opinion about 1, 2, 3, 4, 5 exit?
So will one come out first?
Okay, Vedant is going with 1 should come out first. Okay. Resh, Adesh.
So 1 second.
It's a streamline flow given to you.
So it's either one or they'll come out at the same time. Because
Or not, Vedant?
so it will either one will come out first or all of them will come out at the same time.
Okay.
So one I told because the arc of one, the distance one will cover will be less.
Okay, I accept that. Okay.
Sir, I guess all will come out at the same time.
Okay. That also
So
is one
the
of the
option
things.
is all of them will come out at the same time.
Okay, that also is an agreement and one of the case given. Let's see what will happen out here. Now, if you say all are to come out at the same time, if at all we are to say that all are to come out at the same time, we are of the opinion that omega for all the particles will remain the same. Agreed or not? Remember what is omega? Remember what is omega?
Yes,
Omega
sir.
Yes,
is
sir.
IT. Remember or not?
Yeah, yes,
Yes.
sir.
So if you say that all the particles are to come out at same time, we are sharing our opinion on omega being same in a way. Correct, dear?
Yes, sir.
Yes, sir.
That can be a case. I'm not negating it. I'm not ruling out a possibility. I'll ask you an anecdotal question. And the anecdotal question being, are you aware of how is pressure related to velocity? You all are coming from Bernoulli's theorem studied in 8th standard. You all are coming from practical experiences wherein your parents did ask you to be away from a fast moving vehicle. So can you relate velocity with pressure? What relation? You're also coming from your favorite sport, cricket, where you have the experiences of swinging off ball. So what exactly is swinging off ball, or how is swinging off ball related to fluid mechanics? Can you relate pressure with velocity?
So
That's it.
pressure is directly proportional to velocity.
Sir, it's inversely proportional.
Amphan just 2 days ago, and the situation is very bad, particularly in Kolkata. You can recollect what in 8th standard teacher used to tell you about thatched roof. Thatched roofs are blown away when wind grazes them, right?
Yes, sir.
Yes.
Why does that happen? Then the teacher used to say that is to owe to Bernoulli's principle or theorem, right? Yeah.
Yes, sir.
Yes, sir.
you recollect? Do you have some reminiscence or not? Or you have lost on it? Say so, please. Come.
So,
And
we
please.
didn't learn Bernoulli's principle in grade 8. Like, not me.
Okay,
The same
okay,
here,
okay. Do you have any
Yeah.
reminiscence of it? Any? Nothing. Okay, no issue. In that case, I'll just let you know and see that whether I can make you understand this question otherwise. Pressure and velocity are inversely proportional to each other. Is it okay? Pressure and velocity, which will be proving by the way, are inversely proportional to each other. High pressure means low velocity, or low velocity if the air is blowing. Why you should not stand in front of a train, Train is this. You are here, correct? Train passes. Wind in front of you will pass with the speed of train, correct?
Yes, sir.
And wind behind of you will be moving with lesser speed, correct?
Yes, sir.
Smaller value.
Yes.
Behind you, smaller value of speed for wind movement, and ahead of you is moving with the speed of train, correct? Yeah, because they're in touch with train. Same yes or no?
Yes,
Yes,
sir.
sir.
So velocity of wind in front of you high, and behind of you is less,
Yes, sir.
relatively less. Can you say that?
Yes, sir.
Yes, sir.
Yes.
High velocity means less pressure. So pressure behind of you is higher than pressure in front of you, correct?
Yes, sir.
You will be pushed towards the train. Is it okay? You will be pushed towards the fast moving vehicles. Clear, dear? Thatch roof.
Yes.
Air blowing. Air blow past them very fast, right, dear?
Yes, sir.
Yes,
And
sir.
inside of it, air is almost trapped. Say yes or no?
Yes, sir.
Yes, sir.
So what will be pressure here? Pressure here will be lower than pressure inside. Clear, dear?
Yes,
Yes,
sir.
sir.
What will that pressure do? Push it up. Say yes or no?
Oh,
Yes.
yeah, like an airplane.
Pressure is less. So what will it do? It will push it up. So it will be blown away, correct?
Yes, sir.
Have you ever had an encounter of being seated near to the window in an aircraft? Have you taken a seat near to the wings?
Yes, sir.
Have you seen in what way the wings are molded? It is this way. That
Yes.
means that
Yeah.
the top will be curved and bottom will be flat. Top
Yeah,
will
yes,
be
sir.
curved and bottom will be flat. Why? Why?
So it
Here,
provide an uplift.
Because,
at this point, see, this is the wing, right? This is the wing. It is
yeah.
moving this. Here, the air is to part. Are you getting it?
Yes,
Air is
sir.
coming right here. It is going to
Yes,
the air.
sir.
It is making trail to the air. So what will happen here? The air is to part,
Yeah,
and it will reconcile here. Agreed?
Yes.
Here.
yes, sir.
Yes,
Here
sir.
it is to part, and here it will reconcile. Same yes or no?
Yes,
It is
Yes,
sir.
sir.
trudging through air, correct? If it is trudging through air, here the air will part, and here it is to reconcile, correct?
Yes, sir.
Yes, sir.
Now tell me, if here it parts and travels this distance and reconcile, and this is to travel a flat portion. So which will have to move faster, the curved one or the flat one? In order to keep to time. They are to keep to time. They are to reconcile. Same part will reconcile. Correct? Yeah. It is not that now it will reconcile with something else, some other part. Is it okay?
Yes,
So the
sir.
curved part has to travel fast.
Yeah. The curved part will have to travel faster. So what will happen to pressure here? Less. Why? Pressure velocity inversely proportional. Say yes or no?
Yes, sir.
Lesser
Yes,
than
sir.
this.
Yeah.
Correct. Lesser than this. This will be
Yes,
higher
sir.
than this. Agreed or not? On the
Yes, sir.
wing. Here the pressure will be lesser. Why? Velocity is high. Velocity of air is high. And here pressure will be less. Semi yes or no?
Yes,
Which
sir.
will be
Yes,
high?
sir.
Opposite, I presume. Here pressure will be low and here it will be high, right? Why here it will
Yes.
be low? Why here it will be low? Tell me.
So
So there,
Why
velocity
will
of
here
wind
be
here.
low?
Velocity
So
is high.
because the particles are traveling with greater velocity.
Greater velocity.
Yeah.
Yeah.
So
Particles of air are traveling with greater velocity, so here pressure will be
Pressure
low,
is low.
and here pressure will be high, relatively high. Correct?
yes, sir.
Yes, sir.
So force will be in which direction? Upwards.
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 Force will be pressure multiplied with area will get you force, right here.
Yes, sir.
Yes,
Force
Yes,
will
sir.
sir.
be in which direction? Upwards, and then it will get lifted. Correct?
Yes,
Sir.
sir.
Yes, sir.
Okay. You must have seen cricketers whenever they get sight of ball, they will just take as early as possible, try to grab ball and start rubbing his willy-nilly here and there, right? Yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
Like lunatic, they will start rubbing it anywhere possible, right?
Yes, sir.
Yes.
So are they trying to give extra luster, extra shine, extra glow to ball per se?
So yeah, so they're trying to make it smoother.
Okay, so they are to rub entire of the ball to make it
No, sir. So
shiny.
one side.
Is it that they are to rub entire of the ball to make it glow, to make it
No,
shine?
sir. Only one
No,
side.
so one half.
Why so? Why only one half? Why the partial or preferential treatment to a half?
For the same reason, sir. Like if you rub it at one side, it'll become almost uneven. So then, like one side on the top, air will go like at a faster velocity. So pressure
Yeah,
will become high.
the side of seam, right? Bursting at the seam as we call. So the left
Yeah.
side of seam, suppose is shiny, then the right they will try to keep as rough as possible. And they have been caught knocking the ball as well, right? Yeah.
Oh
Yes,
yes,
sir.
sir.
And one side they want to keep shiny, the other side they want to keep as rough as possible. Reason, when you throw the ball, suppose this side is shiny, and when you throw the ball, then the ball is to see wind get past through it easily, this part, right? It will sweep.
Yes,
Yes,
sir.
sir.
So it will sweep this part, graze this part, and that will happen in quick succession, then this one, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Velocity is high, this part velocity is high, then pressure will be less, correct?
Yes, sir.
Yes, sir.
Happen, it will be an outswinger, correct, dear?
Yes, sir.
Yes,
It
sir.
will swing
Okay.
outside. Why? Because pressure here is low and here will be high. Correct? Yeah.
Yes, sir.
Yeah.
So this is related to swinging of ball. So entire of cricket you can take in the realm of physics. When you talk of spinning of ball, then you have rotational mechanics to relate to, and when you talk of swinging, you have fluids to relate to. Correct? Yeah.
Yes, sir.
Yes, sir.
And we'll learn about why pressure and what's the reason for pressure being inversely proportional to velocity and vice versa. That we'll come to. But to this question first, because this is on what we want to first pay more of attention to. This comes from IU. 1, 2, 3, 4, 5 certainly will not come out at the same time. They will not come out at the same time. And as did air Vedant, one will come out earlier, then 2, then 3, then 4, then 5. But Vedant answer being that it has to travel lesser distance. I think it has to travel lesser distance. Of course, one has to travel lesser distance. But how can I cement my position on speed? If I have to say speed of 1, 2, 3, 4, 5, all are V as of now, and I think you are convinced on them, they will all will V, correct?
Yes,
Yes,
sir.
sir.
They will
Yes,
all
sir.
will V. Fine, they are all V now. And if I say that they are to maintain their velocity, mind you, very important now, class. If I am to say that they are to maintain their, not velocity, speed, they are to maintain their speed, then I'll go with Vedant. Yes, if they are to maintain their speed and one is to travel as seen, lesser distance than the others, so one will come out first. Agree? Clear, dear?
Yes,
Yes,
But
sir.
sir.
Yes.
there's a doubt, there is a suspicion which I do have on their speed. Will they move with same speed through and through? To which the answer, anyone?
No,
Will
sir.
they
No,
with
sir.
same speed through
No,
and
sir.
through? Anyone?
No, sir.
No, sir.
No.
No, they will not move with same speed. They will not move with same speed through and through. As they are moving and following arc, we know they are not to intersect each other. They will follow their arc. But as they are moving, what will happen? Their speed will keep on changing. Are you getting it?
Yes, sir.
Yes,
Yes,
The
sir.
sir.
speed will keep on changing. The speed will keep on changing. And how will it change? Why will it change? That you can answer now. Look at one particle, just briefly. Look at one particle. This particle is moving on a circle.
Yeah. Yes, sir.
Yes
Yes.
or no?
Yes, sir.
This
Yes, sir.
particle, you say or not, dear? Take any particle anywhere. Is
Yeah,
it moving
yes,
on a
sir.
circle? Yes or no? Check it
Yes,
out, dear.
sir.
Yes, sir.
It is moving on a circle. So you have to associate radial acceleration with it.
Yes, sir.
Tensor may not be, but radial you'll have to accept it and associate that there will be a part of radial acceleration coming from the baggage.
Yes,
Yes
sir.
or no?
Yes,
Yes,
sir.
sir.
So radial acceleration is there. Radial acceleration is there means what you ought to say on force. There will be force in this direction, correct?
Yes, sir.
Yes, sir.
And force in this direction means this pressure P2 into area should be more than P1 into area. Very check it, check it, check it. P2 into area, both are radial. Both are radial, getting it? Both are radial, getting it or not?
Yes, sir.
Yes, sir.
The table normal force only will count. So normal force will be this way and normal force will be this way, correct? Yeah.
Yes, sir.
So force which is higher as per radial acceleration account, force P2A will be higher than P1A, agreed?
Yes,
Yes,
sir.
sir.
Yes, sir.
So as you are moving radially outwards, pressure is, what will you say, increasing, decreasing?
So increasing.
You see.
Pressure is decreasing. And accordingly, velocity, accordingly,
Will
velocity,
decrease.
speed, to be precise. Accordingly, speed, tell me dear.
Speed will decrease.
Speed will decrease.
So that is all the more to help Vedant, correct dear?
Yes, sir.
Yes, sir.
That is all the more to help his case. Because when speed was same, then one was to come out. Here, it is no exception to what line he was towing, right dear?
Yeah,
Yes,
yes,
sir.
sir.
Yes,
This
sir.
derivation or this experimentation makes his observation better. Can we say that?
Yeah.
Yes, sir.
Because as we are moving radially outward, what is happening to speed? Speed is decreasing. That means 5 will move with lesser speed, then 4, then 3, then 2, and then 1, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
One is gaining on two fronts. Isn't it, yeah? What are they?
Yes, sir.
One, it has to travel lesser distance,
Less
and second,
distance.
it is moving with higher
Velocity.
speed. Correct,
Yeah.
yeah?
Yes,
Yes,
sir.
sir.
Yes.
So it's a double whammy for the other cases, for the other points, but one stand gains doubly. Accordingly, what we have to say, one will come out first before of 2, 3, 4. So if you can give colors to, and they don't mingle, then you will find this color coming out first. Is it okay, dear?
Yeah,
Yes,
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 sir.
sir.
This is the difference I want to make you cite for streamline motion. Ask any individual, as I have not got except for 2010. Ask any individual this question. If the person is not privy to this being there in Ayurveda, we is to the same line. In general, they will say that omega will remain same, therefore they are all to come at the same time. Or if they are to say that one will come out as Vedant did, then they will relate with distance. They will have no inkling on what will happen to speed, right? Yeah.
Yeah,
Yes,
yes,
sir.
sir.
The answer remains the same as what did Vedant there, but an element being added, and that element will be proved in the time to come. How does, because this I'll be extending, this question of Ayurveda I'll be extending, I'll be asking you later, find equation of velocity with R. Are you getting it? Speed with R. Is it okay? I'll ask you
Yes.
how is speed varying with R. For now, I have told you already that speed will decrease with R. Correct?
Yes, sir.
Later, we will establish what the equation to read the decrement. Clear am I?
Yes, sir.
Yes, sir.
Yes, sir.
Shall happen after Bernoulli's theorem. For now, we are not. Today, I don't think we'll be able to. What's the time?
Sir.
Sir.
225.
Today, we'll not be able to take Bernoulli's theorem. So, fine. Let us keep to this today. Fine, dear.
Yes,
Yes,
sir.
sir.
So can I upload you the answers by today night, 10 or 11?
Yeah, post me the answer and I'll get you the answer set. Okay?
Yes, sir.
So I had a doubt.
Yes,
So
Vedant.
you told yes, so you told to buy the CBS publication Erodov, but
Huh.
that bookshop only had Arihant, and they told that only Arihant is available in whole of the Patna. So my father got
You can
Arihant.
take actually Ariant has got few problem. One, the marking of the question being wrong. B, they have marked few diagrams also wrongly. That's the reason I don't prefer few diagram, particularly in rotational mechanics, 2, 3 questions. They have not marked it correctly. But if you are not getting, in that case, there is
Sir,
no
I can
option
help.
left.
Maybe.
I think you should get online, Vedant. Try online once.
Sir,
So online Amazon
Vedant,
is not delivering it.
not Amazon, not Amazon. Which store did you use?
So Gyan Ganga is in Patna. It's in Patna.
Oh, okay, then I don't know.
Okay, fine. Then you can, for the time, you can take, fine, no issue with that. Few questions which are there incorrectly marked, I'll make you aware of those. Fine. You can go ahead with it.
Okay,
Okay.
thank you, sir.
Thank you, dear. Thank you, Vedant. Vedant, did you get it?
Yes, sir. Yes, sir. So I got the book.
Okay, okay, good.
Thank you, sir.
Thank
You,
you, sir.
dear. Thank you, all of you.